Last video we have seen how to initialize registers, how to transfer the content of one register into another register. So move R1 comma A, transferring A value into R1, initializing R6 with 36, initializing the data pointer with 1, 2, 3, 4, initializing the data pointer higher with 1, 2, lower with 3, 4, nothing but initializing data pointer with 1, 2, 3, 4. Okay, and how to transfer B value into A, 0F0 if pound symbol is not put. So that means it is an address. If you put one pound symbol, hash symbol like this, then this is considered as one number. So here if you see move 0E0, 0E0 is an address, and 25, because pound symbol is there in front of that, this 25 is a number. Move A, this 0E0 is the address of accumulator, 0E0 comma 25 H. You are initializing accumulator with 25. Okay, so you can transfer R1 value into R0 using instruction, data transfer instruction by this. Clear A, you can clear the accumulator content. You can clear a carry flag. CLRC means clear carry flag. Set BC, set B means set a particular bit. C means the carry flag. If you want to set a single bit like carry flag, you can set it using an instruction called as set B. Set B P0.0. P0.0 means port 0, 0th bit. CLR P2.4. CLR means clear. P2.4 port 2 fourth bit, nothing but fifth bit of port 2. You want to clear it, then this is the instruction. Increment is to increment register content by 1. Decrement DEC is to decrement the register content by 1. Add is the instruction to add a particular register content, register value, or one value directly to the accumulator, or register value into register value with accumulator, or two register contents you want to add. So these are the add is the instruction. And SUBB, subtract with borrow. Subtract with borrow. Remember, we have to write CLRC before writing SUBB instruction. Subtract with borrow. So that otherwise it will consider the carry flag set or reset by previous instruction. Apart from subtracting, so if you take SUBB A comma 45, what happens is 45 will be subtracted from A. Apart from this, the carry flag status also will be subtracted. So if the carry flag is 1, A minus 45 minus 1. If the carry flag status is 0, A minus 45 minus 0. That will happen. Mul is the instruction to multiply two numbers. Those two numbers should be there in A and B. Div is the instruction to divide one value with another value. Numerator value should be taken in A, denominator value should be taken in B register. After the div instruction is done, you can you can you will get the remainder in B and quotient in A. So these things we discussed in the previous classes. Now we see little more clearly about program status word. Program status word is an 8-bit register. Among these, 4 bits are mathematical flags. The first one is PSW.7. PSW is a bit addressable register. PSW is bit addressable, means each bit will have one address. You can refer to that particular bit with its address. So it's just like PSW.7 means you are referring to the carry flag. PSW.6 means the auxiliary carry flag. PSW.0 means program status word. 0 bit means that is parity flag. The next one is PSW. PSW dot uh, 2 dot 2, nothing but overflow flag. Overflow flag. So that is the overflow flag. Now, apart from this, there are two more flags. So two more flags. One is the register select 0 and the next one is register select 1. So what are the uses of these two bits? These two bits are used to switch from one register bank to another register bank. So the default register bank is a register bank 0. Now you want to use the 8 registers in register bank 3. You want to use those 7 registers or 8 registers. So then how to switch from register bank 0 to register bank 3, that we see. First we try to understand how the carry, auxiliary and parity flags will get affected, how they will change. So show the status of, with one example, show the status of the carry flag, auxiliary carry flag and the parity flag after the addition of 9C and 64. You take 9C and 64. 9C means 9 means 1001. This is what is the binary equivalent of 9. C, the binary equivalent of C is 1100. The binary equivalent of 6 is 0110, 0110. 4 is 0100. 0 plus 0 is 0. 0 plus 1 is 0 plus 0 is 0. If you add these two numbers, you will get something like this. You'll get something like this. If after adding all the bits have become 0 and the carry got generated. So the carry got generated, no? So the carry flag will become 1. Auxiliary carry flag. There is a carry generated from D3 bit to D4 bit. Upon adding this column bits, a carry got generated into D4 bit. So then auxiliary carry flag will become 1. So the number of ones in the result, P is equal to 0, since the accumulator has an even number of ones. Even number of ones. So it has 0 number of ones. It has 0 number of ones. So the parity flag is 0. The parity flag is 0. Parity flag is equals to parity bit is equal to 0, because here the number of ones in the result are 0 number of ones. 2 ones are there. Then also it is parity flag is 0. Since the accumulator has even number of ones, even number of ones, 2 ones are there, 4 ones are there, 6 ones are there, then the parity flag will become 0. Only one is there, or 3 ones are there, or 5 ones are there, then in that case, the parity flag will become 1. So that is how the carry flag, auxiliary carry flag, and the parity flag will get affected upon the execution of an arithmetic instruction called as add. Now we'll come to RS0 and RS1. So we can switch the other banks by use of this PSW register. So if our PSW, this is PSW.3. If you carefully observe PSW.3, this is 0, 1, 2, third bit is RS0, fourth bit is RS1. If the third bit is if the third bit is 0 and fourth bit is 0, then the register bank that is under usage is bank 0. Okay, now how to switch from bank 0 to bank 1? Now let us suppose RS PSW dot 3 PSW dot 3 is equals to 0. It is equals to 0. Now by default it is uh, register bank 0. PSW dot 4. PSW dot 4 is equal to RS1 is equals to register select is equals to 0. Okay, now I want to use the 8 registers of bank 2. In order to switch from bank 0 to bank 2, PSW.4 should become 1. PSW.3 should become 0. Okay, PSW dot 3 is already 0. Is already 0. You no need to change it. How to make PSW dot 4 to 1? How to make this particular bit equal to 1? So the instruction is very simple. SETB PSW dot 4. PSW dot 4. So we take one small example. Okay, move move hash 5 or hash 5h. So you are loading 5 in R naught. Where is this R naught? This R naught is the R naught register in register bank 0. Okay, now let us suppose if I write PSW dot clear CLR clear PSW dot 3 SETB PSW dot 4. So what happened here? By writing CLR instruction, by writing this, PSW dot 3 has become PSW dot 3, nothing but RS0, register select 0 has become 0. And by writing SETB PSW dot 4, register select 1 has become 1. So with register select is equals to 1 and register select is equal to 0, the register bank which is under usage is bank 2. Now that if you write move R naught comma hash 5 5h, now the instruction is same. The instruction is same. I have written the same instruction here. What is the difference between this and this is this R naught is the register R naught in bank 0 and this R naught is R naught in bank 2. This R naught is R naught register in bank 2 in RB2. So why this is in RB naught and why this is in RB2? Because we have changed this register select to 0 and register select 1 to 1. So by changing this particular 2 bits, you can switch from one register bank to another register bank. Okay, so this is how we can switch from one register bank to another register bank by writing clear and by clearing the respective or by setting the respective RS0 or clearing RS1 or setting the respective RS1 bits according to your requirement. So if RS1 is equal to 0 and RS0 is equal to 0, the bank under usage is bank 0. Okay, if RS1 is equal to 0 and RS0 is equal to 1, the bank under usage is bank 1. Okay, if RS1 is equals to 1 and RS0 is equal to 0, then the bank which is in usage is bank 2. If both register select bits are ones, then the bank that you are using is register bank 3. So like this, we can switch from one bank to another bank by using the 2 bits of PSW, that is program status word PSW.4 and PSW.3. So I hope I made it very clear the usage of these two bits and how the carry flag, auxiliary carry flag, and the parity flag will change according to the arithmetic instruction given. So that we discussed in this particular session. Thank you very much.